We have two problems dealing with angle of elevation and angle of depression. Angle of elevation is where we're looking up an object from the horizontal. So in this case, this is going to be the angle of elevation. In this case, we're looking down from the horizon. It is going to be the angle of depression. So if we, from the horizon, we're looking up, that is the angle of elevation. And from the angle, from the horizon, looking down, that is the angle of depression. And now we do the first one. A tower casts a tower that is 150 feet height, cast a shadow of 160 feet. Now we just need to find the angle of elevation. That is an acute angle with respect to this angle. This side is going to be the opposite, and this 160 feet is going to be adjacent. So we just look for the trig function that has both of those functions. So we're going to have opposite and adjacent. So that's going to be tangent. So first let's let this angle be A. So we're going to have tangent of A is equal to tangent is opposite over adjacent. Opposite is 150 feet. Adjacent is 160 feet. The unit, we don't really need to put it here, but the unit cancel out, and we just have 150 over 160. And after that, we have tangent of A is equal to 150 over 160, and then we can use the calculator and find the inverse tangent and to get the angle. Right. So let me get the calculator. Right. We have a calculator there. So tangent of A equal to 150 over 160. So we can have that, say, tangent of A 150 over 160. So A will be tangent inverse of 150 over 160. We just need to make sure that it is in the right mode. The mode should be in degrees. So mode, I will keep that in degree. And that's good. So we just tangent inverse of 150 divided by 160. Pretty much 15 over 16 will do. So that is 43. Is to the nearest degree, so we just say 43 degrees. So that's the first part of the question. So the first problem. The second problem is this time we have the angle of depression. So from a cliff that is 300 meter height from the river, a surveyor sees a dock that is at the angle of depression of 25 degrees. So this time we know the angle is 25 degrees. That angle be A, and we know that is 300 meter height. Find the distance between the surveyor and the dock. So we're going to ask for this distance. Let's don't know that, so we're going to solve for x. So this time what we have is that 25 degree angles. This is also 25 degree angle because we have parallel lines and a transversal. Those two angles are alternative interior angles. They should be the same. So that 25 and that 25. Now with respect to this angle A, we just name them even though we don't need all of them. Let's see, enough for D. So the angle ABD here, this is the right angle. with respect to 25 degree, 300 meter is the opposite, and x is going to be the hypotenuse. We just need to find a trig function that have opposite and hypotenuse. So that's going to be sine. So we have sine of 25 degree equal to opposite over hypotenuse. Opposite is 300. I just drop the unit here. Hypotenuse is x. And what I'm going to do next is just write this over 1 and cross multiply. So we're going to have x times 25 sine of 25 degree equal to 300. So x equal to 300 divided by sine of 25 degrees. And we bring up the calculator again. It should be, yes, it's still in the degree mode. Every time we use the trig function using the calculator, we need to make sure that it is in the right mode, in degree mode here, right? So that's good. Second mode, right? So 300 divided by sine of 25 degrees, and that's why we have 709. Let's round that to the nearest meters, so 710 meters. Let me zoom out and have both the problem at the same time. Right. Once again, angle of elevation, we're looking up from the horizon. Angle of depression, we're looking down from the horizon. And when we solve the right triangle, we just need to know what do we have, opposite adjacent, opposite hypotenuse, or something like that. We should have a trig ratio, and we go from there.